Welcome to our introduction to graphing parabolas, where I'll be giving you a step-by-step guide to sketching parabolas. Today, we'll dive into two key forms of parabolas, the standard and vertex forms, and explore how changes in the equation affect the graph. We can describe parabolas in two main forms, the standard form and the vertex form. The standard form here, shown as ax squared plus bx plus c, helps us find the intercepts of the graph. On the other hand, the vertex form helps with identifying the vertex and the specific transformations that shape and position the parabola. Let's start by looking at how the A affects the parabola shape and direction. When A is large, like y equals 2x squared, then it goes smaller or narrower. When A is small, then the parabola goes wider like this. If A is negative, then the parabola flips and opens downward. The B term in standard form shifts the vertex of the parabola horizontally. The vertex x-coordinate is calculated using x equals negative b on 2a, which shifts the graph left or right. For example, in y equals x squared plus 2x, this shifts the vertex to the left, where in y equals x squared minus 4x, this shifts the vertex to the right. Finally, C moves the parabola up or down. In y equals x squared plus 1, the parabola is shifted up by 1 unit, while in y equals x squared minus 3, the parabola is shifted down by 3 units. This value also gives us the y-intercept of the graph, as the y-intercept in this graph is also equal to the C value. In vertex form, A behaves similarly to how it does in standard form. The larger the A value, the narrower the parabola, and the smaller the A value, the wider the parabola. Here's an example where A is equal to 2, which makes the parabola narrow, and another one where A is equal to half, which makes the parabola wider. The H in vertex form moves the parabola horizontally. Positive H shifts the parabola to the right, and negative H shifts the parabola to the left. For example, in this example right here, y equals x plus 2 all squared, this shifts the parabola by 2 units to the left. And here, y equals x minus 3 all squared, this shifts the parabola to 3 units to the right. Now we want to convert from standard form to vertex form. So how we would do that is using a method called completing the square. So for example, let's start with x squared plus 4x plus 1 and complete the square. So how we would do this is put this 1 on the other side. This is what you get. And you have to add both sides by this term here, b divided by 2 squared. This term here is what you have to do, where you have to add both sides to. So our b in this case is 4, so 4 divided by 2 is 2, so what we have to do is add both sides by 4. Which equals 3. So this is this thing here, we now can write it like this. So we're almost done here now. And then that. So that's how we convert from standard form to vertex form using the method called completing the square. So what this allows us to do is to see the transformations much more clearly. So from the original graph x squared, we can see by using this term here that is shifting 2 to the left, and this term here is shifting down by 3 units. For most parabolas, or pretty much every parabola, we have to follow these 3 rules in order to sketch them. So the first step is to find the y-intercept. We can do that by letting x equal 0, or you can just simply look at the value of c. And then the second step is to find the x-intercept, which you find by substituting y equals 0. And then the third step is to find the axis of symmetry, which is found by x equals negative b on 2a. And after you found your x value, you can substitute it into the equation to find the y-coordinate and the vertex. So we'll start off simple here by sketching x squared plus 2x plus 1 equal to y. So the first thing was to find the y-intercept, or you can let x equal 0. So if you just let these equal 0, y equals 1. The same as our c value here. So this is our y-intercept. Now to find the x-intercept, let y equal 0. So you get x squared plus 2x plus 1 equals 0. You can factorize that simply by just doing x plus 1 all squared. So we have a double root at x equals -1. That's our x-intercept. To find the vertex, or the axis of symmetry, let x equal -b on 2a. B is just 2, so you get -2, and a is just 1. So you get -1. That's our x-coordinate for the vertex. Now to find the vertex, you just substitute x equals -1 into here, which would give you 0. So our vertex is -1, 0. Now we got our 3 main points, here, here, and here. We can now sketch our parabola. Y-intercept at 1, double root at -1, and a vertex at 1. So go here, and that's our parabola. Now for example 2, we'll go with this example where you can't simply just factorize and get your x-intercept, but I'll go through it. So first step was to find the y-intercept, let x equals 0, or just look at our c value here. So our y-intercept would just be -5. Second step, find the x-intercept. So if we tried the normal way, just to factorize it, there is no way to factorize this. There's no factors of 5 that add to 4. So what we have to do is complete the square. So by doing this, put the 5 on the other side, like this. And remember what I told you? To find the term that completes the square, you have to do b on 2 all squared. B on 2 all squared. So our b is 4. So be 4 on 2 all squared, which just gives us 4. So x squared plus 4x plus 4. Add 4 on both sides, right here. Now with this, we can just factorize this. So we're almost done now. And then x squared minus 9 equals 0. So we've completed the square here. Now the advantage of having vertex form is that we can see the axis of symmetry, or the vertex, instantly. The vertex would just simply be hk. So this is h and this is k. So it would just be 2 and 9. -2 and 9. So we've got our vertex, we've got our y-intercept. Now all left is our x-intercept. So we can just find our x-intercept by factorizing the equation. So you get x plus 5, x minus 1, and you get your x-intercepts to be -5 and 1. Now we can just sketch the parabola. So this is 1, -5, the vertex at -2 and -9, and -9. So you'd sketch it like this. And this would be your parabola. Let's recap. In both standard and vertex forms, A determines the width and direction. In standard form, B affects the horizontal shift, and C affects the vertical shift. In vertex form, H controls the horizontal shift, and K controls the vertical shift. Together, these values allow us to transform the shape and position of the parabola. Thanks for watching, and I'll see you guys next time.